PteroDynamics is an aircraft design and manufacturing company, and we've built our company around a key innovation for a new type of vertical takeoff and landing aircraft we call a transwing, that has wings that fold to transition between configurations that are optimized for taking off and landing and a configuration that's optimized for cruise flight.
The proprietary design of the transwing, which allows the wings to fold, take off vertically, rapidly get into cruise flight, and land vertically as well, gives it a unique capability that takes away a lot of the trade-offs that we see in other types of VTOL aircraft, whether they be tilt wing, tilt rotor, tail sitter, or lift plus cruise, the traditional four formats for VTOL. Our format of a dihedrally folding wing called the transwing is incredibly unique, patent protected, not just the design, but also the avionics and controls of the aircraft.
PteroDynamics is an unmanned aircraft design, build, and test manufacturing. We're an original equipment manufacturer for unmanned aircraft systems and OEM. We are building the most efficient, most effective, the safest unmanned aircraft. We specialize in vertical takeoff and landing, fixed wing airplanes, so we can get the flexibility, the range, the speed and endurance of a fixed wing with the flexibility of a helicopter.
So what makes the Transwing UAS so different from other UAS platforms? Well, really it's the configuration itself. We have this transverse folding wing. And why is that important? With the transverse folding wing, we have the ability to not only blend more seamlessly between VTOL and fixed wing flight, but we can accept less compromise. By having wings folded in tight around the fuselage, you have lower rotational inertia, preserving control bandwidth, and allowing us to either reduce overall propulsion system weight, increase performance, or maintain control bandwidth to operate in austere environments. And then of course our transition. We have a very controllable transition. It's very robust, it's very adaptable, and then on the wing, it's a conventional aircraft.
So we talk a lot about the aircraft matters and how distinct our technology is and why it's better for certain things. It's important to understand what we mean by that. This is our XP4 aircraft, and you can see it's a very compact footprint. This actually transports in a box in this configuration. So you basically open up the top, you do your pre-flight, and you check. There's nothing to assemble. It's very unique, but it's a 13-foot wingspan that has a very small operating ground footprint. So it allows you to take off and land in much more confined spaces. The other thing too is that it can weather vane into the wind. If the wind's coming from this direction, it's not flowing over the airfoils, so it's not creating lift. So if there's gusting and gusts drop, you don't lose altitude when the gusts drop, which is a real challenge with other aircraft. So we can operate in much windier and gustier conditions. We have the same propulsors that are used for lift as for cruise. So these four motors are used to lift the aircraft, but also to cruise the aircraft. Many other designs have separate propulsion systems. When we're in cruise configuration, we can go into beast mode. That's what we call it. We can light up all four of these motors and use it to dash much faster, climb much faster than other designs that don't use the same propulsors for lift as for cruise. And because we use the same propulsion system, we have more weight to devote to either a greater payload weight fraction or a longer range, a longer endurance, a faster speed, all the other things that sort of eat up the efficiency of an aircraft.
I think what excites me most about being at PteroDynamics is we are not only developing this novel technology, we're not only developing these new aircraft, but we're also developing a company. Not many people get to do that. Everybody who sees this aircraft fly is just absolutely amazed. You really don't get an appreciation for it until you see it fly. The first time I saw it come in to land as a Harrier pilot, I was actually pretty surprised at how fast it came to the landing spot and how late it transitioned to VTOL mode, vertical takeoff and landing mode. There's a tactical benefit to this, and there's an energy benefit to this. By holding off that transition as late as possible, you spend more time on the wing and less time with your motors having to work really hard to stay in hover flight.
It's biomimicry. It actually models what a bird does when it folds up its wings. And if we've ever seen a bird leap off the ground and suddenly spread its wings and get on flight like an eagle, that's what this aircraft does. The industry in aerospace, they've been looking at VTOLs and trying to find ways to do this. And the founder, Val Petrov, conceived of it and made it reality.
Kind of a shift happening in the market today where smaller aerospace companies are increasingly able to take on the large defense prime contractors. And we're able to do that for a number of reasons. Primarily, it's because we're smaller and more nimble and able to adapt and iterate our technology at a much quicker pace and with lower costs. What we're doing here is innovating, as opposed to just engineering. What we've done at PteroDynamics with our Transwing design is we have leapfrogged to a whole new generation, a whole new type of vertical takeoff and landing aircraft that's unlike anything else.
In terms of social impact for sustainability, we understand that this aircraft as an autonomous unmanned vehicle can do its part to begin to do things in a more sustainable way. So when it comes to maritime logistics or automated cargo delivery, the potential for this aircraft to be a contributing factor to do things more efficiently with less impact on the environment is an incredible opportunity. So there's the now of that. But there's also the now of the ability to do things more efficiently from the customer perspective. When companies lose millions of dollars because their oil rig has gone down, or because in maritime shipping there's an inefficiency and we have supply chain logistics problems and ships can't get offloaded fast enough, the opportunity for us to be able to move cargo back and forth from ships coming into port, get them turned around faster, is an enormous opportunity for shipping companies who make money on the margin.
Instead of starting with sectors like the government sector, the defense sector, the commercial sector, what we think more is sort of in first principles. An aircraft that doesn't need a runway can deliver anything from anywhere to anywhere, right? That's the concept. Now that thing can be cargo, that thing could be a sensor, camera system doing search and rescue, border patrol, supporting the police department, to LiDAR, maybe you're at a mining operation, you're trying to understand how much material you've already mined and trying to volumetrically evaluate that. Anything that you need to move from here to there is where vertical takeoff and landing aircraft come into play. And the farther the there is, and the more you have to travel horizontally, the more valuable our Transwing VTOL aircraft innovation is. The way that we've been able to leverage our partners in the marketplace is bringing best-of-breed technologies into our platform. So some of our partners are able to deliver technology to our platform, but some of our partners are also able to deliver expertise in a particular geography or a business domain, whether it's commercial shipping or offshore oil and gas mining or the defense industry and so on.
We have a lean and agile team that is committed and motivated to take this fantastic technology and adapt it into an object that's a useful tool in the marketplace.
We have such an amazing team, and it matters so much. It comes to the culture and the attitude, the work ethic, the capability, the expertise, the education, the experience. There's nobody at my company that I wouldn't want to be here or I think that we could do better. Everybody is awesome in the roles that they're playing. We're going to be bringing more people on, we're going to be expanding, filling in other roles, but just could not be more pleased and more proud of the team that we have.
The creativity I get to be involved with is very rewarding. I feel like I'm really on a winning team. I believe that we really hire the best in the field, and I am honored to be here.
So day to day here at PteroDynamics, we're trying to get flights in every day. It's pretty straightforward to fly. I've got Vigilant Spirit control station to run everything, and we've recently started exploring other ground stations. We have a TAC integration that is coming along nicely, so we're able to take off and land just with a tablet and a radio. Yeah, this aircraft is unlike a lot of others I've dealt with in the past. You can just click a button to launch it, click a button to land it, and you can kind of not worry about it. It's all electric, pretty simple design. Our test site here is about an hour to the east of Colorado Springs from our shop. We've got about 700 square miles to play with. So we can fly here. We've got a 4 nautical mile ring around our facility, and then the corridor out to another 500 square miles. We can fly up to 8,000 feet AGL. Being able to fly every day kind of helps showcase our mission readiness and maturity as a platform. And if you're able to fly every day, then hopefully our customers will also be able to fly every day.
The Transwing is just a really, really fun aircraft. You know, it's a blend between so many different worlds. There's a lot of mechanical aspects that have to be attended to really, really well. There's a lot of computational complexity that goes along with the geometry, and the geometry changes. There's a lot of physics at play. There's a lot of fluid dynamics that you don't encounter in other more fixed setup aircraft. And when you put that all together in one big ball of yarn, and kind of try to untangle all the ends, it makes for a lot of really, really interesting problems to solve. And when you get good solutions to those problems, again, it's like magic.
Recently, the PteroDynamics team participated in an exercise with the US Navy on a cruise between San Diego and Pearl Harbor aboard the USS Curtis Wilbur, a Flight 1 DDG. The purpose of that cruise was to put the Transwing in real-world conditions, conducting logistics supply missions as part of our Blue Water UAS project with the US Navy. It was really important for us to have the ability to test in real-world conditions. Not often do you have the ability to go and operate out in the middle of the Pacific Ocean, and our team was able to spend every day flying the aircraft in multiple different conditions to not just prove the technology, but provide the test artifacts and the data for us to improve how the aircraft is used at sea. Autonomy is a key enabling factor to getting our technology into the marketplace. The Transwing is proven by the XB4. We can operate this aircraft autonomously from takeoff to landing, and a lot of the focus now is turning that from a unique flying object into a very useful tool, augmenting the pilot and the operator with automation and functions to reduce the workload and allow that person to operate that aircraft more safely. We're going to go and excel ourselves in the marketplace, not only in existing missions, but new missions that people haven't thought about right now. The Transwing does things that other aircraft cannot, which opens up a market opportunity to accomplish things with UAS that others didn't think were possible.
We're bringing the product to market in two different segments, both in the defense sector as well as in the commercial sector. And we think it has profound capabilities and applications in both of those areas.
This aircraft is a 30-year design. This is not an interim capability that you're going to move on to something else. This is the 30-year design. This aircraft is going to be around for many, many years, and we're going to continue to iteratively improve the performance and the capabilities of it over time. But this is the first 30-year UAS out there.